Hello, and welcome to Astronomy Daily. I'm Anna.
And I'm Avery. It is Friday, March 27th, 2026, and our producer has given us an absolutely stacked show today.
We are literally 5 days from a crew of 4 astronauts launching around the moon for the first time in over 50 years. And today, those 4 people touch down in Florida.
We've also got the most detailed look at Saturn ever captured. Lightning on Jupiter that makes Earth storms look like a birthday sparkler, and a 50-year stellar mystery finally cracked open by a Japanese space telescope.
Plus, we're narrowing down the short list of exoplanets most likely to harbor alien life. And we have a juicy update on that dramatic rocket scrub from yesterday.
Spoiler, it was a boat.
It was absolutely a boat. Let's get into it.
Let's go then.
All right, story 1. And Avery, this one is really happening. Today, as we record, the Artemis 2 crew is flying into Kennedy Space Center.
Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, all from NASA, and Canadian Space Agency astronaut Jeremy Hansen. 4 people, 1 rocket, and they are now officially on site.
NASA Administrator Jarrett Isaacman and Canadian Space Agency President Lisa Campbell were there to greet them on the tarmac this afternoon. The crew also answered questions from the media.
Now, just to set the scene, the SLS rocket and the Orion capsule are already sitting on Launch Pad 39B at Kennedy Space Center. They rolled out on March 20th. Everything is in place. The target launch window opens Wednesday, April 1st at 6:24 p.m. Eastern Time.
And April 1st is not a joke. This is genuinely happening. A 2-hour window on the 1st, and if they need it, opportunities continue through April 6th.
The crew has been in quarantine since March 18th, keeping their health locked down before this 10-day mission. They spent the quarantine reviewing procedures at Johnson Space Center in Houston, Texas, and now the rest of the countdown happens here in Florida.
This mission is going to take them farther than Earth than any human has been since Apollo 13 in 1970, about 5,000 miles beyond the moon. It won't land, but it will swing around the back of the moon on a free return trajectory and come screaming back to Earth at around 25,000 miles per hour.
Victor Glover will become the first person of color, Christina Koch the first woman, and Jeremy Hansen the first non-American to travel beyond low Earth orbit. And for Canadians listening, Jeremy Hansen arrives in Florida today for what is going to be the ride of his life.
We are going to be covering this story right through launch. Stick with us. Astronomy Daily is your front row seat to the most exciting human spaceflight moment in a generation.
Story 2, and this one is visually stunning. NASA has released a new set of Saturn images, and they are genuinely the most comprehensive view of Saturn ever created.
This is a collaboration between 2 of humanity's greatest telescopes, the James Webb Space Telescope and Hubble Space Telescope. Now, these 2 observatories were launched 31 years apart. Hubble went up in 1990, Webb in late 2021. But when you combine their observations, you get something extraordinary.
Hubble observed Saturn in visible light in August 2024, capturing all those familiar golden cloud bands and the iconic rings. You get the colors, the subtle atmospheric variations, the sheer beauty of the thing.
Then Webb looked at it in infrared in November 2024, just 14 weeks later, and the picture completely transforms. The rings glow brilliantly because they're made of highly reflective water ice. You can see deep atmospheric storms, jet streams, and a mysterious gray-green glow at the poles that scientists think may be linked to auroral activity or high-altitude aerosols.
One of the most poignant details in this release, Saturn's famous hexagonal jet stream at the North Pole is just barely visible in these images. And scientists say this could be among the last clear views of it for decades, because the pole is heading into a long winter darkness that won't lift until the 2040s.
NASA describes what the 2 telescopes together can do as slicing through Saturn's atmosphere at multiple altitudes, like peeling back the layers of an onion. Hubble covers the upper clouds, Webb dives deeper into the chemistry. Together, they give researchers a 3-dimensional picture of how this whole system works.
And Webb's wide-angle view captured 6 of Saturn's moons in the same frame, including Titan, which is massive and hazy, and Enceladus, that little world with a subsurface ocean that astrobiologists find so tantalizing.
We will link to these images in the show notes. They are genuinely worth 5 minutes of your time just to look at them. Saturn is out there looking absolutely magnificent.
Story 3. And I want everyone to picture the most dramatic lightning storm you have ever seen on Earth. A real cracker. Thunder rattling the windows. Now imagine that, but 1,000,000 times more powerful.
That is potentially what is happening in Jupiter's atmosphere, according to new research from the University of California, Berkeley, published this week in the journal AGU Advances.
The study used data from NASA's Juno spacecraft, which has been orbiting Jupiter since 2016, specifically its microwave radiometer. That instrument was designed for studying the planet's atmosphere, but it turns out it's also brilliant at detecting the radio signatures of lightning.
The clever bit was that the team focused on a period in 2021 and 2022 when a normally storm-filled belt on Jupiter went unusually quiet. That meant Juno could pinpoint individual isolated storm systems, what the researchers call stealth superstorms, and directly measure the power of lightning within them.
The results are remarkable. From 613 detected lightning pulses, the power ranges from roughly comparable to an Earth lightning bolt all the way up to 100 times more powerful. But because of uncertainties in how radio frequencies compare across the two planets, some of those bolts could be up to 1,000,000 times stronger than anything on Earth.
And these storms were generating around 3 lightning flashes per second. On one flyover, Juno detected 206 separate microwave pulses in a single pass.
Lead researcher Michael Wong describes it really well. On Earth, moist air rises because water makes it more buoyant in a nitrogen atmosphere. On Jupiter, the atmosphere is mostly hydrogen, so moist air is actually heavier and sinks. It takes enormous energy to push it upward, and when those storms finally break loose, they release all of that stored energy in extraordinary ways.
What I love about this is that the Juno mission has been delivering incredible science for a decade now. And even as the spacecraft ages, it's still finding ways to rewrite our understanding of the solar system's biggest planet.
Okay, on to our next story today.
Story 4. And this is one of those stories where astronomers get to say, we finally did it after 50 years.
The star in question is Gamma Cassiopeia. If you look up at the distinctive W shape of the constellation Cassiopeia on a clear night, the middle star of that W, that's it, visible to the naked eye, about 550 light-years away. And since 1976, it has been blasting out X-rays around 40 times more powerful than you'd ever expect from a star like that.
The plasma generating those X-rays was hotter than 100 million degrees, and for decades, nobody could agree why. Was it magnetic activity on the star itself? Was there a hidden companion pulling in material? The debate has raged across multiple research groups for half a century.
Now, thanks to Japan's XRISM space telescope, that stands for X-ray Imaging and Spectroscopy mission, developed by JAXA in collaboration with NASA and ESA, the answer is finally in. The culprit is a hidden white dwarf companion.
The key instrument is called Resolve, a high-precision microcalorimeter on XRISM that can measure X-ray spectra with extraordinary accuracy. The team observed Gamma Cassiopeia 3 times, in December 2024, February 2025, and June 2025, covering the full 203-day orbit of the binary system.
What they found was that the superheated plasma generating the X-rays was moving in sync with the hidden companion, not with the bright B star everyone could see. That's the clincher. First direct proof that it's the white dwarf, not the star itself, driving all that high-energy activity.
And it turns out this white dwarf is magnetic. Its field is funneling material from the star's surrounding disk toward its poles, where it releases all that energy as X-rays, like a tiny but ferocious cosmic vacuum cleaner.
The implications go well beyond this one star. Astronomers have long predicted that about 50 to 70% of B-type binary stars might have white dwarf companions, but solid evidence has been hard to pin down. This result confirms a whole new class of binary systems that had previously only existed in theory.
Lead researcher Yael Nazé at the University of Liège put it beautifully. There has been an intense effort to solve the mystery of Gamma Cassiopeia across many research groups for many decades. And now, thanks to XRISM, we have finally done it. A very good Friday for stellar astrophysics.
Story 5, and this one comes with a movie tie-in, which I am absolutely here for.
If you haven't seen Project Hail Mary yet, the Ryan Gosling film based on Andy Weir's novel, it's currently in cinemas, and it is excellent. The premise is that humanity discovers a tiny microorganism called astrophage is consuming the sun's energy, and one scientist is sent on a desperate solo mission to find the answer at a distant star.
And this week, real astronomers at Cornell University's Carl Sagan Institute have published a paper that asks essentially the same question the movie poses. If we were building a real Hail Mary spacecraft, where would we send it?
Lead researcher Professor Lisa Kaltenegger, alongside a team of undergraduate students, combed through data from the European Space Agency's Gaia mission and the NASA Exoplanet Archive. There are over 6,000 known exoplanets. From that enormous list, they've narrowed it down to 45 rocky worlds sitting in their stars' habitable zones, where liquid water could potentially exist on the surface.
The list includes some names that will be familiar to our regular listeners. TRAPPIST-1, D, E, F, and G, about 40 light-years away. Proxima Centauri b, our nearest stellar neighbor, at just 4.25 light-years. LHS 1140b, a dense super-Earth about 48 light-years out, and quite a few lesser-known candidates that could prove just as interesting.
What's powerful about this paper is that it's not just a list, it's a strategic roadmap. It tells you which worlds are best suited for transmission spectroscopy with JWST, which worlds are targets for future direct imaging missions, and which have the tightest constraints on habitability.
There's also a more conservative list of just 24 worlds within a tighter three-dimensional habitable zone. And if you account for the uncertainties in stellar measurements, the 45 could expand to as many as 73.
Kaltenegger summed it up perfectly. Our paper reveals where you should travel to find life if we ever built a Hail Mary spacecraft. The search for alien life just got a shortlist. I find that genuinely thrilling.
Finally today, the boat story we teased at the beginning of the show.
Story 6. And yesterday we told you about that extraordinary scrub at T-3 seconds for ESAR Aerospace's Spectrum rocket. The most dramatic last-second halt you could imagine, right on the edge of potentially making European space history.
And we didn't know why. The countdown got all the way to 3 seconds before engine ignition, then nothing. Controllers called a scrub. We knew there was a hold in the countdown, but the exact cause wasn't confirmed when we recorded yesterday.
Well, now we know. It was a boat.
An unauthorized vessel entered the danger zone around Andøya spaceport in northern Norway during the countdown. The range had already been delayed when the boat first appeared, and by the time the boat cleared and the range was reopened, the propellant temperatures on board the rocket had shifted. The window was gone.
To add insult to injury, the countdown had actually cleared T-3 seconds. The engines were moments from igniting. ESAR Aerospace would have potentially become the first company ever to launch a rocket to orbit from European soil. And a boat said no.
No new launch date has been announced as of now. ESAR has said they're working to determine a suitable window, and they'll need to assess the propellant situation and any technical reviews before they can reset for another attempt.
Now, we should note, this kind of range safety protocol exists for a reason. Keeping people out of danger zones during rocket launches is genuinely critical. No one is blaming range control here, but the timing could not have been more painful.
We'll keep tracking this one. ESAR's Spectrum rocket is a genuinely significant vehicle, 28 meters tall, capable of carrying up to a ton of payload to low Earth orbit, designed and built almost entirely in-house near Munich. When it does reach orbit, it will be a historic moment for European space capability.
The mission is called Onward and Upward. And that is exactly what ESAR will have to be. We're rooting for them.
And that is your Astronomy Daily for Friday, March 27th. What a week it has been, and honestly, with Artemis 2 5 days from launch, next week is going to be even bigger.
We will be covering every step of the countdown, right through to liftoff and beyond. Make sure you're subscribed so you don't miss a single episode.
You can find us on all the usual platforms at astronomydaily.io and across social media at AstroDailyPod on X, Instagram, TikTok, YouTube, Facebook, Rumble, and Tumblr.
And if today's episode sparked something for you, a question, a thought, a theory about whether that rogue boat was actually a disgruntled rocket enthusiast, drop us a message. We love hearing from you.
From all of us here at Astronomy Daily, keep looking up. The universe is not done surprising us.
See you tomorrow.
Astronomy Daily.